Hello, this is Tony. I'm a math and science tutor here at OpenWisdom Education. Today we'll be going through one question from the 2020 HSC Physics paper, particularly targeting Module 7, the nature of light. And before it gets too annoying, I'll be turning off my video. Now let's get on with the question. Question 27. The following apparatus is used to investigate light interference using a double slit. The distance y from the slits to the screen can be varied. The adjustment screws vary the distance, d, between the slits. The wavelength of the laser light can be varied across the visible spectrum. The diffraction pattern shown is for a specific wavelength of light. Explain two methods of keeping the distance between the maxima at A and B constant when the wavelength of the laser light is reduced. Now feel free to pause the video right now and have a go at the question yourself. Otherwise, I'll be going through exam strategies and how you will be able to answer this question. With any long response question like this, you would always want to highlight or understand what are some of the key points this question is trying to ask. With the highlighted parts shown here, we should start to think about what are some of the relevant topics and what is the diagram telling us, as in what is the experiment here. If possible, think about what are some of the equations we can use in your answer. You can also see that I have highlighted the marks for this question. It's 4 marks. This is because in a HSC paper, the mark is usually an indicator of how much time you should spend on the question. To maximize efficiency, I would recommend a 4 marker should take you no longer than 6 minutes to do. Structure-wise, you should always consider using paragraphs. Avoid using dot points or tables, because that's the easiest way teachers can take away marks from you. Content-wise, we should go back to what are some of the relevant syllabus dot points. Now, we already know that this question is targeting Module 7, the nature of lights, but more specifically, this question is talking about the wave model. And in Module 7, we learned about Huygens' wave model, where he said, all points of a wavefront of light in a vacuum or transparent medium may be regarded as new sources of wavelets that expand in every direction. It should be clear enough now that the diagram here is talking about Young's double slit experiment, and he was able to explain diffraction and interference pattern, which supported the wave model. Now here are some of the relevant HSC dot points that you should refer to when you answer this question. When doing a long response question, always consider turning a 3D diagram or any chunky paragraphs into a 2D diagram that you can work with. Any labels can be included in your answer to support any written information you provide. Now with the diagram on the right here, we know that this is talking about the equation d sine theta equals to m lambda. In this case, we assume d is constant, which means that decreasing the wavelength will directly decrease the angle. So we can consider what must be changed here experimentally to maintain the angle and the distance. Now first, we want to identify the issue, which is what is the distance determined by. Now we can refer to the equation highlighted above, d sine theta equals to m lambda, and using this, we will be able to explain impacts of reducing the wavelength. Now for the two methods, suggestion here is that we do method 1. It could be decreasing separation between the slits. And method 2 could be shifting the screen further to increase linear separation. Now, doesn't matter how you structure an answer, as long as you cover all the information here, it should be efficient. It's always important to go through any criteria or sample answers given by the past papers, because doing more of those questions like this and looking through the sample answers, you would formulate an idea of what the markers are looking for when answering long response questions.